Good evening, everybody. Can you hear me okay? All right, I'm Christy Ruskowski. I'm a member of Champaign County Master Gardeners Program Committee. We are the group who brings you a presentation every fourth Tuesday of the month. And our presentation this month, we are just delighted and honored to have as our guest, Dr. James Angel. Jim completed his bachelor and master's degree in atmospheric science at the University of Missouri. And then he wised up a bit, moved east to CU, that would be Champaign-Urbana, where he earned his doctorate from UIUC. He has worked his entire career at the Illinois Water Survey here in Champaign, during which he served for more than 20 years as the Illinois state climatologist. So he is indeed an expert on climate. He lives in Champaign with his wife. They have 2 sons, 2 daughters-in-law, and 3 grandchildren. Most recently, Jim has served as leader and co-author of a comprehensive report titled An Assessment of the Impacts of Climate Change in Illinois. That was published earlier this year, and it goes by the shorter, much sexier title, The Illinois Climate Assessment. I think all of us are aware of climate change, and Jim's goal tonight is to help us and other gardeners understand how climate change will affect our gardening activities. So with pleasure, I'd like to introduce you to Dr. Jim Angel.
Hello, everybody. Thank you, Christy. Hello, everybody. That was a great introduction there, and we're going to talk about climate change and how it impacts the world and how it impacts all of us. And so we'll talk about that, and we'll talk about the new report that came out, and we'll get her started here. Let's see. Do the old screen share. All right, so can everybody see that?
Yes, we can, Jim.
Okay, great. All right, so get that. Do it this way. So yeah, so here's some logistics on this webinar about the microphones and so forth. And I guess we probably should have this on a little earlier, but anyway, so just some background information on how this will run, and then you can submit questions through the chat box. And this presentation will be recorded for later viewing on the YouTube channel, so you can always go back to that. And also, I will make this slide presentation available to anybody that wants to look at the slides in more detail. So we're not giving away any state secrets or anything here. So I'm very comfortable with sharing these slides, and you can use or reuse those as you so please. So we'll jump in here and we'll talk a little bit about climate change in my backyard. We'll be a little egocentric here and talk about some of the things that I think about, and there's probably a lot of things that you think about in terms of climate change and its impact on gardening. And we'll talk here kind of in general. One of the first things I want to clarify is this idea of climate and weather. So weather is really kind of the short-term conditions of the atmosphere, and climate is the long-term picture of the climate or the weather in the atmosphere. So they're actually 2 sides of the same coin, in that today's high temperature of 89, well, that was a weather event, but you add that up over time, and those become statistics that describe our climate for Illinois and elsewhere. So there's all kinds of catchy little phrases like climate is what you expect and weather is what you get. The other one I heard is the climate is the clothes in your closet, and the weather is what clothes you're going to wear that day. So it kind of gives you an idea of what's the big long-term picture versus the short-term. But as I said, these are all interrelated, and we'll talk about some of these very specific weather events and how they tie back into overall climate conditions. So just kind of give you a brief summary of what's going on at the global level. We talk about the greenhouse effect. It actually is a natural effect. Some of the sunlight that hits the Earth, it warms up the Earth's surface and the atmosphere, and the CO2 and other gases in the atmosphere trap that heat and keep the Earth rather warm. In fact, if it weren't for that, our average temperature is still being around 60 degrees Fahrenheit would actually be closer to zero. So it'd be more like living on Mars or the moon or someplace like that if it weren't for those heat trapping gases. So those make this planet livable. Problem is that we're adding more gases into the atmosphere. So that's the root of the problem that we're talking about tonight.
Jim.
And I'll
Jim.
yes.
I'm sorry to interrupt, but we can see your notes view.
Oh,
Can
okay.
you swap your display settings?
Oh, okay. Yeah. Let
Sorry
me do
about that.
here. Let's see. Let's see. I get the.
Yeah, I think there it is on display settings, right? And you can swap.
Okay, there it is. Yeah. All right. Yeah. Sorry about that. So we talk about greenhouse gas levels, specifically CO2 levels. We actually can get data from ice cores. You can drill down and get ice core samples as that ice accumulated over the millennia. It traps the atmospheric gases in the bubbles in there. So you basically just thaw it out and look at the gases that are contained in those ice layers. And we can reconstruct that pretty far back to 1,800,000 years pretty specifically. And the highest levels we have are actually today. In fact, I just looked before we started this, that the current level at Mauna Loa is about 413 parts per million. So a little higher than this graph. But you can see that we're off the charts as far as the levels of CO2 concentrations in the atmosphere over the last 800,000 years. And you have to go way back to an earlier period to see levels that are as high as they are today. So it's by far and away above the natural environment as far as CO2 levels. Background is kind of about in the order of, I always say about 275, 250 or thereabouts is kind of the pre-industrial levels. And it's no mystery of where the CO2 levels are coming from. This is the distribution of sources across the United States. So, fossil fuel related to electricity and heat production and transportation, as well as industry and agriculture and other activities have produced quite a bit of CO2 levels into the atmosphere. And those amounts have been increasing over time. So it's no mystery about where that's coming from. Now, it has a big impact on temperatures. We know that just in the more recent period, in the last couple of 1,700 years, that just like the CO2 levels, our air temperatures around the globe have skyrocketed or are much above the background natural climate variability that we've seen before then. In fact, you really have to go back to the last 125,000 years ago to see temperatures like we're seeing today. So this is all being driven by the introduction of the increase in our CO2 levels from our industrial revolution. I always like this graph because it's a nice way of tying in both the temperatures and CO2 levels for the last 140 years or so across the globe. So in this graph, the blue bars indicate below the long-term average, and the red bars above the long-term average. And then you got overlaid with the CO2 levels. And you can see there's a pretty much a one-to-one relationship between those. So as the CO2 levels go up, so do the temperatures. And what's really outstanding in this is since about the late 1970s is that we've seen this steady, persistent increase of the temperatures over time to the present. And so that it's a pretty strong smoking gun, as you might think, of this relationship between the CO2 levels and the warming of the atmosphere. And we also can confirm this with climate models. We look at other factors like volcanoes and the solar activity and other things that are going on in the atmosphere. And these other natural features do not explain this warming. It's almost exclusively from the increase in CO2 levels.
Jim,
And this is just yes.
I'm sorry, we've had a question come through.
Okay.
How is ag, forestry, and other land use contributing to greenhouse gas emission?
Yeah, well, so part of it is that they just from the activity. So, plowing and hauling grain and so forth. Also, the production of fertilizer releases greenhouse gases. Also, and probably this is probably one of the bigger things, not so much in the United States, but in other parts of the world, is the deforestation that's going on for cattle grazing. So in South America, for example. So those kind of things are increasing the greenhouse gases. And I will say on the side that there are opportunities in agriculture to bring back some of that by sequestering that into the soils based on agricultural practices such as cover crops and no-till farming and things like that. So there are some opportunities to gain some of that back. And this is just this map here is just a reminder that when we talk about global warming, it truly is global, and that this is around the world. So all the major continents are showing warming, and in major portions of the oceans as well. And probably the one thing that's kind of interesting about this map here is that in our part of the United States, kind of the central part of the United States here, is that we haven't seen quite as much warming as we've seen on the West Coast or in the northern latitude. So compared to other parts of the world like Europe and Africa and Australia and China, we've actually not been as bad off as some of those areas. So they've certainly have felt the warming much more so than we have here. We also have other changes going on in Illinois in particular. 200 years ago, 300 years ago, it was tall grass prairie and woodlands across the state. And then we've moved over to intensive agriculture in most of the state, with corn and soybeans being our primary ecosystem there. And then finally, we also have urban environment, which has its own unique climate, in the sense that we have urban heat island where you have higher temperatures, and especially in the urban, more downtown areas, from all the concrete and parking lots and paved roadways and so forth. So those tend to warm up more during the day, but also hold that heat in longer at night as well. So the differences between the countryside and urban areas can be pretty pronounced, on the order of several degrees. Also with the urban areas, when you pave over everything, anytime you have rain events, you get much greater runoff from that, and much more immediate runoff. So you make it problems of flash flooding or flooding in general much worse than they would be in rural areas. So there's those factors going on as well in Illinois and the rest of the Midwest. So I think the important takeaway from this part is just that we're now in the warmest period in modern civilization, and that it's the human activities that are the dominant causes of this warming. Also, the other thing about all this is, as you warm up the atmosphere, you also get more evaporation, and as a result, you get more precipitation. In fact, if for every degree you warm up the atmosphere, you get about 4% more water vapor, and that's fuel for the next thunderstorm that passes through. So we see this strong pattern of not only warmer temperatures across the globe, but increased precipitation in many areas. And this is especially true in the central US. So the central part of the United States, we're on the order of about 10 to 15 degree or 10 to 15% increase in precipitation. And that extends all the way out to the northeastern United States. Meanwhile, it's been getting drier in the western US. So Illinois has been getting wetter, but it's also been our neighboring states as well. So it's kind of a central US theme of these overall wetter conditions over the last 100 years. So this is looking at the first part of the 20th century and the first part of the 21st century here. It's also, we've seen an increase in the heavy precipitation events, so that you're getting more frequent 2, 4, 6, and 8-inch rain events. And this map shows that in the Midwest here, we're getting about a 42% increase in the amount of precipitation in those top 1% events. So big increases in the Midwest and in the Northeast and then the high plains states, maybe not so much in some of the other parts of the country. So more rainfall and more heavy rainfall. And then it creates problems for Illinois in that we see more flooding, more soil erosion, more water quality issues as a result of that. So this is the assessment that we were talking about. Got some links here. We can also share some of those at the end. I also have another link at the very end of the talk. So it's kind of these URLs kind of gruesome here. So, but if you go to Nature Conservancy for the Illinois chapter, you can dig around in I think in the press release and find that. And this is a project that was done between the University of Illinois, Northwestern University, and the Nature Conservancy to do this assessment. And we'll kind of jump in on some of the findings from that. So here's the observed temperature changes for Illinois, and we kind of added some of the surrounding areas as well, but to give you an overall picture. But overnight temperatures have warmed quite a bit. They're on the order of 1.5 degrees to 2.5 degrees or more in parts of Illinois. Average daytime temperatures not warming quite as rapidly. So it's really most pronounced in the nighttime temperatures. And you can see that on the table on the left here, where you've got winter, spring, summer, and fall. Actually, the biggest changes in Illinois right now are in wintertime, nighttime temperatures. The smallest changes are in daytime high temperatures in the summertime. In fact, they're actually a slight cooling trend. And there's this relationship between precipitation and temperature. So we've had these wet winters and springs. And so when we get into summer, many times we're getting rain or we have very moist soils. And so it's actually holding down the daytime temperatures a little bit. So we haven't seen the pronounced warming in the daytime temperatures in the summer as you have seen in other parts of the country. And just by way of reference, the 1930s were some of the hottest daytime temperatures for Illinois in the summertime. So this is the difference between the early 20th century and early 21st century. All the seasons are showing warming in the nighttime temperatures, most of them in the daytime temperatures as well.
Jim?
Yes.
Going back to the precipitation map, someone asked why dry in some places and wetter in others?
Okay, and this one maybe. Yeah. So some of these patterns are in the nature of how the precipitation falls in these different areas. So here in the central part of the United States, most of our moisture comes up from the Gulf of Mexico. So from Texas on over and all the way up to Minnesota and the Dakotas, that most of our moisture comes to the Gulf of Mexico. And then we have the systems that interact with that. If you go farther west, there's the storms that come off the Pacific. There's also the monsoon season, which is a kind of more of an July, August time frame for out there. So they just have different mechanisms for how that precipitation plays out. So some of these things can work for you. In our case, having warmer temperatures and more moisture out of the Gulf of Mexico and more evaporation feeds into more precipitation here, whereas some of the other factors inhibit the precipitation out west, especially in parts of California and Arizona there.
Okay. And then someone asked, why were the 1930s so warm?
That's a good question. We know there's been some research that looked at El Nino and La Nina, and there's some thoughts that there was some pretty big La Nina events out there in the Pacific Ocean that was perhaps impacting our weather here in the central U.S. Also, with these type of events, they kind of feed on themselves. So we saw this in 2012, where we had this big drought in in not only Illinois, but most of the US there. Whereas once you get the soils dried out, it stops raining, and you've lost that local source of moisture that gets recycled, and so that it just stays dry, and then it stays hot. So once the soils are dried out, it's much easier to heat them up. So you get this kind of hand in hand, the hot, dry weather go together. And so there's probably some of that feedback going in there as well. So those things, the larger circulation patterns, and then also the ongoing droughts in the Midwest and central US during that time period fed into those really hot temperatures. So July 1936 was our hottest month on record for Illinois. And we had many stations that were regularly over 100 degrees day after day in July of that year. So pretty brutal. And you think about it, that's before air conditioning. So that's kind of mind numbing there. So here's the observed precipitation changes, kind of zooming in on Illinois and the surrounding states here. And you see in the table there, we've got the trends both in inches increase and also as a percent increase. So wintertime about 1/2 inch, but especially in summer, we've gained almost 1.5 inches. So overall, we've gained, gosh, about on the order of about 15%, or about another month's worth of precipitation. So we're in a much wetter climate now than we've ever been in recorded history for Illinois. It's just a very, very wet environment, especially compared to the early part of the 20th century. Also, another thing, kind of side note on this, is that not only are we seeing more wet conditions in summer and spring, but also in winter, and more of these big time winter events that fall as rain rather than snow. So we've had several years in a row where we've had systems move through, especially in Missouri and Illinois and Indiana, kind of along that area, that have produced tremendous amounts of rain, 4, 5, 6 inches or more. And these cause of massive flooding and loss of life and significant damage across large areas. So, this is like this one is in let's see, where do we go here? So this one is in January of this last year. And just a tremendous amount of rain, and at a time of year that we generally don't get that much rain. If we do get something, that falls as snow instead of rain.
Imagine my poor Charlie.
So here's the flip side of the coin. So no surprise here, this is on the drought side of things. So the areas in red are past droughts, and you can see that the 1930s droughts were pretty significant there. So the more red, the more drought, and the lower the numbers there, the more significant those droughts are. So from 1900 to 1964, we had about 1, 2, 3, 4, 5, 6, 7, about 8 droughts, major droughts. Since then, we've only had 2 in 1980 and 2012, and neither one of those were as bad as the droughts that we saw in previous decades. So we're trending towards not as much drought, and the ones we do get tend to be short-lived. So we might get 2 or 3 or 4 months of intense drought, and then it's over. Whereas we had several droughts before 1965 that were multi-year droughts. And so that's another facet of the Illinois climate that has changed over the last century. Now, the future is a little murky on this about how this will play out on the future. And we can touch on that here in a minute when we talk about projections. But statewide average snowfall, a lot of year-to-year variability. If you're here in the 1970s, ooh, look out! That's where we had a lot of the really snowy winters in Illinois. So we had those are the ones that set the record for the modern era. And since then, it's kind of tapered off a little bit, but it kind of bounces back and forth. 2014, we had a lot of snow, kind of rivaled some of those winters in the 1970s. So we still have quite a bit of snow at this point in time, but no really long-term trends there, other than it just bounces around quite a bit. if we look into the future, we'll talk about that for a bit here. You know, look, the future projections are always kind of tricky because you not only have to know what the climate's going to be like, but you also have to know what our economic activities are going to be like, what our emission levels are going to be like, what kind of policies will be into place. And so it becomes very tricky about trying to figure out what's going on. So one of the things they've done is they've picked some scenarios that are possible, not probable, but are possible in the future, because we don't know which one is likely to play out. So the two that we used in this report were the higher scenario, which is really kind of doom and gloom. It's we continue to pump CO2 carbon or CO2 levels into the atmosphere, that they keep going up through the end of the century, burn more fossil fuels, more coal, and really don't have any policies in place to regulate that. So it's kind of the, you're not supposed to say this, but it's kind of the worst case scenario. So it's a very gloomy scenario. But then we also have a second one that we looked at, which is what we call the lower scenario. And that's one where we kind of start tapering off in our CO2 levels. And we actually start to drop the emission levels down, not quite to zero, but much lower than they are today. So that's a much more optimistic one. If you look at some of the policies that are coming into place, that's probably more likely to happen than the other one. So remain optimistic. And these are two significantly different scenarios with big impacts on how things play out, both globally and here in Illinois. In fact, if you look at on the right-hand graph there, you see what the high scenario, we could see warming globally about, it could be on the order of 6 to 8 degrees or more. Whereas with the lower scenario, it's closer to about 3 or 4 degrees. So it's a much more moderate outcome. Still warming, but not as bad. So
Yeah.
we did, yes.
And we did have another question come through, going back to the drought slide.
Oh, okay.
How does the drought in northern Illinois compared to past droughts?
Yeah, you know, that one's pretty intense. It's very localized just for the northern part of the state there, but there's some areas that are in pretty significant drought right now. Let's see, I think it was Rockford. I was just talking to Trent Ford, our new state climatologist, the other day about this, and I think they're on track for their driest year to date. On record, and their records go back to about the 1880s or 90s or so. So so for parts of Illinois, that's a very significant drought occurring right now. And you know, that's another thing about some of these past droughts. They were big droughts. They were not only Illinois, but large chunks of the Midwest and elsewhere. Whereas we're seeing more of these little intense pockets of drought this year and previous years. So it's more localized. So we'll talk about projected temperature changes. And I'll show a series of maps of these kind of a similar pattern, in that the top panel is the lower emission scenario, and then the bottom panel is the higher emission scenario in all of these. And so, and then on the left-hand side is mid-century, and the right-hand side is late century. And so the takeaway points in all of these is that what you'll see is the strongest reaction to in terms of temperature and precipitation and all those variables is to the high scenario at the end of the century. So that's where you get the strongest reaction. It's mildest with the lower scenario at mid-century. So that's pretty standard across these. So for Illinois, it's about 3 to 4 degrees warming by mid-century and 4 to 5 degrees warming by late century under the lower scenario. And then under the higher scenario, it's 4 to 5 degrees warming by mid-century and 8 to 9 degrees warming by the end of the century. So that's a huge difference, both in terms of mid-century to late century, but also low scenario to high scenario. And to kind of give you an idea, you know, 3 to 4 degrees, that doesn't sound like that big of a deal. But that's that when I was talking about that July of 1936 being so hot, that was running about 4 to 5 degrees warmer above the long-term average. So that's how it plays out, in that you get 4 to 5 degrees warming shows up as much more pronounced than what it sounds like when you just say the averages. You especially see that on the extreme temperatures, and we'll show that in a second here. Projected precipitation. This one's not quite as spectacular. By under the lower scenario, it's about 0 to 6% by the mid to late century, so not a big change. You know, we've already increased by about 10 to 15% in the last century. So continuation of that wetter trend, but maybe not quite as intense. Under the higher scenario, with about 3 to 6% wetter at mid-century and about 4 to 10% wetter at the end of the century. So a little stronger with the higher scenario, but not a whole big difference. And these are the kind of changes we're already kind of used to seeing in terms of precipitation, based on what we've seen so far. But it also means that we're going to have an increase in the heavy rain events. So we've seen trends already in a number of extreme precipitation events. So on the left-hand side is a bar graph of number of days with 2 inches or more averaged across stations and across the state. And it's gone from, somewhere in the ballpark about 1.5 or so up to 2. And now in this most recent period of 2015 to 2019, there we've gotten up to 2.5. So big jump in the number of heavy rain events. 2 inches is about the time where you start to see flooding, both in urban and rural areas. And so that's where it starts to be problematic. Those are projected to change into the future. In fact, on the order of, we could see percentage-wise, 30 to 60% under the lower scenario, and even more so, a 90 to 120% increase in the number of days under the high scenario, especially by the late century there. So this is probably a bigger concern than the average precipitation increasing. It's the impact on the extreme events. And it's kind of the same story with extreme temperatures. So this is a number of days, 100 degrees Fahrenheit or higher. It's pretty rare in Illinois right now to see 100 degrees. You know, we might see a day or two. I don't think we saw it much this year, certainly not in central Illinois. And it's especially rare as you go farther north. You get into the Chicago area, it's about once every 2 or 3 years that you might see a 100-degree day. Under the low scenario, by mid-century, it's depending on where you are, between 0 and 12. By the end of the century, it's increased to 6 to 18. And by under the high scenario, it's 6 to 18 by mid-century and 14 to 48. Or 18 to 48 by the end of the century. So it's scorching hot conditions by the end of the century. 100 degrees, that's pretty unbearable. It's hard to do anything outside. It's a threat to animals and humans and plants. And so that would be a pretty catastrophic outlook to go down that path. It's still no picnic to go down these other paths. So, like I said earlier, that warming of 4 to 5 degrees by mid-century could play out to many more days of 100-degree weather. Growing season length, I guess this is maybe good news, bad news thing, we've seen an increase in the growing season in Illinois. It's on the order of about a week or two, depending on where you are. Much of the increase has been in the spring. So we're getting warmer springs, and that has increased the length of the growing season there. Not so much in the fall. The fall trends are pretty muted, but we're gaining ground on the growing season length. And even under the low scenario, we could get about another week or two or longer by mid to late century. And under the higher scenario, it could be even longer. We could get an extra month out of it by the end of the century. So it's good news, bad news, because we it's good news for growing plants, but it also means there's a longer growing season for weeds and insect pests as well. So everything kind of goes along with that. So it may be kind of a wash on terms of the overall impact. But we can expect to see that play out as we get warmer moving on into the future, that we'll see a longer growing season. And as that is implied, is that we'll also see a shorter winter season or non-growing season as well. So we talk a lot about the impacts in the report, and I'll just highlight a few here as they relate to our backyards. One is that there's several water issues in Illinois that are affected by climate change, and these include the flooding that I mentioned earlier, which affect water quality in urban areas, and these cause economic damage and environmental damage and public health hazards. We're also concerned about extended summertime droughts that may impact water supplies. So overall, we've seen fewer droughts, but what we do see are these more intense droughts, kind of like what we saw in northern Illinois this year. Also, with the increased precipitation intensity, we've had a lot of trouble with increase in the nutrient loads in our rivers and streams in Illinois. And that's another major headache and we're trying to do nutrient loss reduction efforts in Illinois. And that's what we're up against, is this increased precipitation intensity.
Cham,
Yes.
someone typed in the box, do you think bird migration patterns will change?
Yes, that's very possible. You know, a lot of our migration, bird migration, not only is what happens in Illinois, but also across the Midwest and on into Canada. Several years ago, I worked with DNR to look at the duck and geese hunting season in Illinois, and try to measure what the impacts were of that. And what they were finding is that specifically duck and geese migration was happening later, and also is more sporadic than it used to be. So it used to be we'd have the onset of winter in November and December, and it pushed all the ducks and geese south, and they would many times continue going all the way south down into Louisiana. And now with their milder winters, they're not moving as far or as fast as they used to. So at least in that kind of migration in those two groups of birds, it's had a significant impact on the hunting season in Illinois. So there's kind of an example of how hunters are being impacted by climate change. And there's the kind of same story with fishing too, with water temperatures. And let's see. So there, in fact, well, I think I got some slides here. I'll talk a little more about that. So as I hinted at earlier, the weeds, pest, and disease impacts. Now, this is for agriculture, so we're talking about crops here, but the same thing for the garden. They're expected to increase due to the warmer winters, the increased spring rainfall, and the higher temperatures. Problem is that we're also seeing increased pest and disease resistance, which may make these problems even worse. So, especially in the agricultural industry, a lot of the pesticides that they use and other techniques of crop rotation and so forth have been lessened because of some of these resistance factors that are coming into play. So we're probably going to see the same story in our gardens as well. More pest and more weed pressure on our gardens as well. Specialty crops, fruits and vegetables. So here again, there's commercial, but it also applies to your backyard. I guess maybe the good news is that the plant hardiness zones will shift northwards, so you might be able to grow things now in the future that you can't grow now. You know, peaches are pretty dicey for central Illinois, and especially in the northern part of the state, but that may not be true in the future. So we could see some of that. But then on the flip side is that when you get these warmer temperatures, it could hurt other crops moving forward as well, like apples that may require the chilling hours to actually be productive. So you have to have cool weather for them to do their thing in the winter time. So they've got to, and you can tell I'm not a biologist by that description there, but they need chilling hours to kick off the whole process for producing fruit later in the spring. And also the extreme heat in the summertime, especially if we get more of those really hot days, will impact farm labor and agritourism as well. And it'd be the same story in your backyard. Higher temperatures, more stressful, more harmful to work in your backyard during the summertime. So also we have big impacts on public health that also are relevant to our backyard, in that, many things we're talking about: the heat waves, the floods, the drought, and worsening air quality with higher temperatures. We're going to see uptick in the number of ticks and mosquitoes. We could see more heat stroke and heat exhaustion injuries and infections from the more extreme conditions, contaminated ground drinking water, respiratory problems from mold and mildew, and worsening allergies and asthma. And so those are a concern. So like I said earlier, with the growing season, we'll get a longer growing season. We're also get a longer pollen season as well, as you can see in that right-hand map. And in the middle map is the number of heat-related hospitalization rates in Illinois. And so I kind of think of heat problems as being kind of a Chicago thing, but downstate we have heat trouble as well, especially in urban areas where they don't have access to healthcare quite as readily. So those are going to be some stressors moving forward as we work in our gardens with the high heat, this higher incidence of flooding and all the things that go along with that, as well as water quality and air quality issues. So some impacts on ecosystems. This is probably one of the things that that I wanted to point out tonight was that some of these projection changes, there's going to be some winners and losers in the ecosystem. But the challenge is that the rate of change is much more rapid in the past. So, we've always had natural changes in the ecosystems in the state, but these are happening at a much more rapid rate. So it's much harder for the ecosystems to adapt to that or adjust to that. So there's going to be some winners like sweet gum, post oak, and hackberry that'll thrive under this warmer, wetter climate. And then others will struggle, especially the ones that prefer the colder conditions, like Ohio buckeye and basswood and the quaking aspen. So there's going to be, and we kind of see that with animal life as well, and that we'll see some species start to get chased out, especially cold water fishes. Some other will thrive. In fact, here, kind of the weird side story is that in the last couple of years, we're starting to see armadillos in southern and central Illinois, which I always thought of that as kind of a Texas thing, but here they are coming into Illinois because with the milder winters, and they're able to push northward. And so that 100 years from now, when we talk about quote native species, we might be talking more about armadillos and less about some other birds and other critters. So I think things will look a little different there. So, and this also brings up another point I wanted to mention at this stage, is that in terms of trees in your backyard, first of all, there's going to be some that'll be more stressed than others as we continue on this warmer, wetter climate. But also in terms of planning for the future, the complication is that we still have the cold winters. In fact, if you look at this is a plot of the average temperature in Illinois for the winter times for the last century, and you can see there's a lot of year-to-year variability. So even though we're warming over time, we can still have some very cold winters. So you really can't introduce warm species into Illinois too quickly, because they could still get clobbered by these really cold temperatures. In fact, what was it, 2 years ago, we got down to -35 at Mount Carroll. So we can still get pretty darn cold. So that's probably going to be a bigger challenge for trees than it is for perennial species or perennial plants moving forward, because it's just harder for them to adjust and recover from these kind of conditions. So in the backyard, I would say, and these are the things I'm kind of working on myself. So in my backyard, as the title says, trying to go native with more native species, just because I feel that in Illinois, the native species are pretty robust to climate change. They're used to the climate of Illinois, so they're better adapted to our winters and summers, the hot summers, cold winters, and dry conditions and wet conditions. And so you can fine tune those for your yard. But also the other things is that reduce reliance typically on water, fertilizer, and pesticide compared to bluegrass, which I'm trying to get rid of. So that also impacts both in terms of sequestering carbon. I think it does a better job, deeper root systems than bluegrass. Here I'm picking on bluegrass, but also things like fertilizer needs those, you burn fossil fuels to produce the fertilizer and also to bring that to transport that. So by taking those out of the equation, you're at least making a tiny effort to reducing your carbon footprint. And then the other upside is that it supports wildlife that is under increased pressure from climate change. So all those come into play. Also, on a very specific case, and as we move towards a wetter climate, rain gardens and bioswales can slow runoff and moderate flooding and improve water qualities. And so these are big deals, especially in urban areas, which, as I mentioned earlier, tend to have a high percentage of paved surfaces. By doing this, we can lower the impacts of these very heavy rain events. So there's concerted efforts in many cities to make this happen, especially in the Chicago area. There seems to be a lot of effort in this regard. So it's another example of how you can do your part for climate change there. And I would just say, to kind of wrap things up here, is that human-induced climate change is happening in Illinois. We've got plenty of observations that have shown that over the last century, and that these observed changes include the warmer weather throughout the 4 seasons and more precipitation, and especially more heavy rain events. And those are expected to continue on into the future based on the projections that we've seen so far. And those have significant impacts on both the natural environment as well as our gardens, and on us personally in terms of our personal health and well-being. And so actions taken to reduce the greenhouse gas emissions can help us avoid the worst of the impacts. So that I talked about the higher scenario versus the lower scenarios. You can see there was pretty significant difference in those. So I think with the policies and there was the new bill that was signed in Illinois, forget the exact title now, but it's the towards more renewable energy and phasing out the coal and natural gas power plants. Those are the kind of steps that we want to take to lessen the impacts. So with that, I'll stop here. And here's another link to the report. This is a more permanent link that's actually, it will be at the University of Illinois, but there's a couple other ways you can get to it as well. So I thank you for your attention, and I'll be happy to answer any questions you might have.
Yeah, Jim, there were a few in the chat box. First of all, back to birds, will we also see a different biodiversity of birds living here all year, do you think?
Yeah, that's very possible. One example of that, they're reminded almost daily, is the Canada geese, which in theory should be migrating southward every winter. Instead, they just stay here. So that's an example of the mild winters changing the migration habits of a species. That's not my area of expertise, so I'm kind of limited on what I can say about the biodiversity of the birds living here. But it'll be a challenge because we're the bird species and the plant species and everything else are all kind of intertwined there, and there's some timing events there that you don't want to get wrong. So you don't want birds migrating into the region before there's food available, and or vice versa. So that can be a problem. So I know that's a concern from the bird people.
Yes, it is. Yeah, and another question that was typed in the box. Do you think that locally we're adequately addressing infrastructure issues to accommodate the climate changes?
I would say we are behind on that. And I've done a lot of work on heavy precipitation events and how they impact infrastructure. So just that one segment alone there, yeah, we're always behind, I think, on that in terms of building structures. And I think also the other thing that's starting to come into play is that the idea that, well, maybe the solution isn't just to keep building bigger bridges and dams and sewer systems, that we need to do this investment in green infrastructure. So the rain gardens and the bioswales, as well as things like permeable pavers so that water can soak through instead of run off from parking lots and things like that. So I think there's we've kind of broadened our horizon on what we think about in terms of infrastructure. But yeah, we're behind on that, and that's just on the heavy rainfall side. Temperature side, it's even scarier because we get that's one scenario of over 40 days of 100-degree temperatures. That would take down any power grid that we've got running right now.
All right, great. Oops. So I've been putting a few resources in the chat box here. If anybody wants to grab onto those.
Oh yeah.
Illinois Indiana Sea Grant has some great publications out there.
Jim, you had said that you would make your slides or your presentation available. How would people request that?
Yeah, well, let's see. I don't know if you guys have any way of storing that. I mean, I could certainly just, if you email me, I could just send it as an email.
Or if you just like to send me the presentation, I can share it with everybody who's registered.
Oh, okay. All right, that would work great.
If you're okay with that.
Sure.
But yeah, another comment in the box says to reminder that the East Central Illinois Master Naturalist Tree and Shrub Sales open until October 3rd while supplies last, so opportunity to buy locally. No other messages in the box though, Jim.
Okay.
Okay, well, Jim, thank you so much for talking with us. It's a little scary, I must say. We all hear about climate change, but when you see incrementally what's happening, I think we have to be really concerned.
That's right.
All of you who attended today, thank you so much. There is a poll available here, and we really would appreciate if you could answer those few questions. One of the things that's really important for us is that you give us some feedback on what kinds of programs you would like. So if there are things that you would like addressed in our evening programs, if you could just send Tab, is there a email at the end of this, or can they just send it to the email of the Master Gardeners?
Yeah, they can email me directly.
Okay, because we have found that some of the best programs that we've had have been suggested by those who've attended them. So we would really like to hear from you. So Jim, thank you again. Thank you to our audience for their attentiveness, and I guess that will be it for the evening.
All right.
Thank you, Jim. Thank you, Christy.
All right, are you
Thank
gonna,
you.
you'll leave?
Yeah, I launched the poll, so I'll keep it up for another minute or
Okay.
so. But if you're finished and want to just hit that little leave icon in the bottom right corner, or at least that's where it is with mine, I will end the Zoom meeting here in just about 30 seconds or so.